Is the screen visible to you?
It's visible.
ma'am.
Okay, fine. So now we are going to see about the stoichiometry. Okay. Yeah, shall we go for it now? See what is given about the stoichiometry. Yesterday, from all of you have solved and you got the same answer. Both of you, Pritam and just one. What is your answer? Pritam said 3 point. Yeah, Pritam,
Yes, ma'am.
what is your answer? 3 point.
I got 3.84.
Answer 3.4. What about you, beta? One, have you solved it or not?
Ma'am, I
No,
can't
ma'am.
see the screen.
Will it not
Yeah, now we can.
it is visible or not?
Now it's visible.
Fine. Just it or not? Jaswant, have you solved or not?
No, ma'am.
Huh?
No, ma'am.
You should see whatever task is given to you. There is a certain purpose behind it, right? Yes or no? Each
Yes,
and
ma'am.
everything I can give you with solution, but then if everything I will do, what you will do, right? Your learning should.
Hello, ma'am.
Fine. Clear. Now see about the stoichiometry, what I'm going to tell you. See, one of the most important aspect of the chemical equation is that when it is written in the balance form, we have learned about the POAC already, where we are going to calculate the percentage of that particular molecular weight by without balancing the chemical equation, without balancing, by knowing its moles only, right? But then
Yes.
stoichiometry is a concept where you have to do the calculation by balancing chemical equations. Means if you are going to know the stoichiometry, that time you should balance the chemical equation first, and then
What
only
do
you're
you
able to do that.
what do you mean by that? Stoichiometry.
Sorry, I'm not getting you
Like,
loudly.
what do you mean by stoichiometry?
Stoichiometry is a fraction ratios. Stoichiometry is a what we can say, it's a quantitative relationship between the various reactant and products. Quantitative with respect to moles, quantitative with respect to mass, quantitative with respect to volume, etc. Understand? Stoichiometry is a quantitative relationship in between reactant and product in the chemical reaction. Got it?
Yes, ma'am.
Just Dhananjay. Yes, what is stoichiometry? It's a quantitative. Do you know the quantitative and the qualitative difference? What do you mean by quantitative? It's related to numbers. And qualitative is related to the quality or the texture, right? Or the appearance. Just a minute. Just change my place because here is some network issue. I'll go at a proper place, get back to you. Just a minute, okay? Yeah, am I audible now? Yes or no?
You're audible.
Students, are you there?
Yes, ma'am.
Actually, there's a network issues. I'm active, so that problem is arises. Don't worry. Henceforth, I'll be sitting here where network is proper and connectivity is proper. Okay. Just give me a minute. We'll move to the stoichiometry. Okay, I gave you the difference in between qualitative and the quantitative earlier, right? So what I said about the stoichiometry, it is a relationship in between reactant and product, and that relationship is a quantitative relation. Okay, means with respect to mole, with respect to mass, with respect to volume. Clear? Clear? Just one, Preetham, Dhananjay, a basic concept you understand about the stoichiometry. What is exactly stoichiometry? Yes?
Yes, ma'am.
Show me thumb if you understand, then only I can proceed. Yeah, good. Fine. Now see what is given here, signals of chemical significance, right? So let us consider the balanced chemical equation they have given you. This is the balanced chemical equation. See here, PBS plus lead sulfide react with the four hydrogen peroxide molecules. You get lead sulfate PbSO4 plus 4 molecules of water. Correct? What is the reaction? PbS
Yes, for
plus
4 plus
4 moles of hydrogen
H2.
peroxide, H2O2. You will get lead sulfate PbSO4 plus 4 moles of water, 4H2. Fine. See, the molar ratio of reactant PBS and H2O2 in which they are react together is 1:4. You can check it. Check. PBS, 1 mole of PBS, right? It react with what? 4 moles of H2O2. So the ratio of these two is nothing but what? 1:4.
4.
Isn't it? Yes.
Yes.
Ratio of two reactant is 1:4. Now, if we go to the product ratio, mole of PbSO4, right? And it will form 4 moles of H2O, water molecule. And this ratio is also 1:4. Clear? Yes?
Yes.
So reactant ratio is 1:4 and even the product ratio is 1:4. Got it?
Yes, ma'am.
Okay. See now next. Now, if you see the initial mole of PBS and H2O2 of the reaction, okay, that takes place not necessary 1 and the 4 respectively. Also, it is not to be molar ratio 1:4. Understanding means if you take a 1 atom of PB, it will also react, okay, PBS, it will also react and it will form the, it will react with the H2O2 and it will form the certain product.
We can't see your screen.
Right?
We can't see your screen.
And right? Screen. Due to maybe network issue. Check it here, second point, what is given to you? The molar ratio of 2 products. Now you are able to see?
Yes.
Or not?
Yes, ma'am.
Fine. The molar ratio of a 2 products, that is PbSO4 and H2O, being formed in the reaction is also 1:4. Correct? The initial moles of PBS and H2O2, the reaction to take place is not necessary to be 1:4 respectively. Means if to do this reaction, it's not necessary that PBS and H2O2 should be in the ratio 1:2. It should not be, means like your product also should not be in the ratio 1:4. It is not necessary. So one can start the reaction with 1 mole of PBS and H2O2 in any molar ratio. But the ratio of lead sulfate and H2O2, which are reacting with, always be in the ratio 1:4. Means to start reaction, they should not be in 1:4. Connectivity lost हो रही बार बार पता नहीं क्या हो रहा है इसमें. Am I audible, students?
Yeah, but your voice is breaking.
Still it is unstable. Huh? Yes, Pritam?
Your voice is breaking.
Pritam, just... Huh?
Your voice is breaking.
Come again, I'm not able to hear.
Your voice was
Yeah, I
breaking.
know, I know. I'll do one thing. I'll resolve this. I'll connect with you again, and I'll reschedule your this class again, maybe by tomorrow, because today is a connectivity issue at my area, I guess, and it's occurring since yesterday. I'll resolve this problem and I'll get connected with you. Till the time, if you want, I can share the PDF with you so you can go through it, and it will be quite easy to you understand all the things. It's fine.
Yes, ma'am.
Jaswant, Dhananjay, Dhananjay, Jaswant.
Yes, ma'am, it's fine.
Jaswant, it's fine.
Okay, ma'am. Fine,
Because
ma'am.
actually I wanted to complete this. It's really very important point, and once it would be done, we have to solve number of problems. But then because of connectivity only, I completely first of all, I am embarrassed completely in front of you. I'm not able to like get connected. And the second thing is what? I'm losing my connectivity with the content. And again and again, it get disconnected. So, and I hope same thing you're also facing. So till the time, whatever time it will be run properly, smoothly, I'll explain you terms. If in between it get lost, so you uh, assume that the class would be end, and this compensation I'll give you in another class, means one extra class I'll take for you. Okay.
Okay, ma'am.
Okay.
Okay. Now see what I said you means to start the reaction or to end the reaction, ratio of your reactant and product, it must not be 1:4. It can be react with any ratio. So it can be start with any ratio, right? But then when they react with each other, their composition and the ratio would be fixed. That is 1:4. Okay, fine. Keep it in your mind always this. 1 mole of PbSO4 and 4 moles of water will be formed for each mole of lead sulfide being consumed. Means if 1 mole of lead sulfide is heated in the reaction, ate up by the reaction, that time it will produce what? 1 mole of lead sulfate and 4 moles of water. Understand? So this you
Yes.
need to keep it in your mind. So your products are also in the ratio 1:4.
4.
Clear?
Yes, ma'am.
Fine. So what is given here? The stoichiometric coefficient of a balanced chemical equation is a molar ratio and not the weight ratio. Please keep it in your mind. It's very important because when you solve the problem, you have to take a molar ratio only. You don't have to take a weight ratio. So what they said, stoichiometric coefficient of a balanced chemical equation is a molar ratio. They are not weight ratio. Suppose somebody gave you weight, then you don't have to take it granted for the problem solving. You just have to consider molar ratio only. One can use the balanced chemical equation for the quantitative estimation of reactant and product. But if one does not have the balance equation, it is very difficult to calculate the amount of reactant consumed or product being formed. And hence, what is important for you? What is important for you? To write the balance chemical equation. Once you write the balance chemical equation, you will come to know how many moles of reactants are used and how many moles of products are formed. How many moles of reactant has been consumed and how many moles of products are formed. It's not about only the moles. You will come to know how many, suppose if it is in a liquid state, or sometimes volume would be given, mass would be given, you will come to know how much mass has been used, how much mass has been consumed, right, and converted into the product, right? And at the same time, you will come to know about the volume also. How much of volume of reactant is used to produce a certain amount of volume of the product, correct? So this is very important to writing a balance equation while solving or doing the quantitative relation in between the doing stoichiometric quantitative relation in between reactant and product. It is very essential to write the chemically balanced equation. Fine. Yeah. Okay, I'll do it. I'll off my camera. Fine. Now, just now I have seen. Okay, fine. So it's visible to you all. Just unmute yourself and speak up.
Yes.
Yes, ma'am.
Yeah, fine. So this reaction is given to you. That is equation for the combustion of hydrocarbon. It's a stoichiometric relation of reactant and the product. X is nothing but a number of carbon. Y is number of hydrogen. Okay, plus X plus Y upon 4 is equal to oxygen. Combustion reaction means what? Any hydrocarbon burn in a presence of oxygen will form a carbon dioxide, water, and tremendous amount of energy would be released. Correct? Yes or no? Normal reaction. When
Yes.
any hydrocarbon which consists the carbon and hydrogen, right? It reacts in the presence of oxygen, you will get carbon dioxide and water. And at the same time, energy is released. They have not given here energy, but then it is essential in the reaction. So if your hydrocarbon have X number of carbon and the Y number of hydrogen, that time, how much oxygen would be used? That will be X plus Y upon 4. This is the stoichiometric ratio of reactant. Okay. And how much carbon dioxide and the water would be produced? That would be X number of carbon dioxide plus Y by 2 number of water molecules. Right? So this is a stoichiometric ratio into product in the combustion reaction. Okay? Fine. Please write down this reaction in your notebook once. Right? So there are the different type of stoichiometric relation and the calculations in the chemical reaction. What it will be? That are mole-mole relationship, mass-mass relationship, mass-volume relationship, and volume-volume relationship. And these all things we have to see in a detail. Fine? Have you wrote this equation or not?
Yes.
Fine. So shall we move forward? Yeah. So first point we are going to see the mole-mole relationship. Right? For that, they have given us one chemical reaction, that is when nitrogen molecule react with hydrogen, it will produce a ammonia. Is it balance equation? No, right? We have to balance it. How many nitrogen here? 2. Here it is 1. To convert it into 2, we are going to multiply it by 2. So 2 ones are 2 nitrogen and 2 threes are 6 hydrogen. Here only 2 hydrogen, and to balance it, we need to multiply it by 3 hydrogen, correct? So number of atom at the LHS is equal to number of atom at RHS. Correct or not?
Yes.
Yes. Yes.
Yes.
So
Yes,
how are you going to write balance equation N2 plus thrice H2? You will get what? Twice NH2. Sorry, NH3. So if you see 1 mole of nitrogen react with 3 moles of hydrogen to give 2 moles of ammonia. Correct? Yes or no?
Yes.
1 mole of nitrogen gas react with 3 moles of hydrogen gas to give a 2 moles of ammonia. Correct? So they are in the ratio what? 1 as to
3,
3 as to 2.
2.
Correct? They are into the ratio 1 as to 3 as to 2. Right? And when reaction is happening between nitrogen and hydrogen to produce ammonia, they will be always in the same ratio like 1 as to 3 as to 2. Clear?
Yes, ma'am.
Okay. Now see what is given there next. So one problem is given to you. Find out the number of moles of NH3 form when 4 moles of NH2 react with sufficient amount of H2. This is a problem. If you want, you can write. Shall I write it in a big letter? Yeah?
I am.
Yeah. Find out question.
Number
Find out number of moles
of NH3. 4
of
moles.
N2, sorry, of NH3 formed when 4 moles of N2 react with sufficient amount of H2. Sufficient amount of H2. Clear? So we have a balance equation already for this, right? I mean not to explain how we have to balance.
Yeah.
N2
N2 plus 3H2.
twice H will get what? Twice NH3, correct?
Yeah.
Already we have balanced it, right? So 1 mole of nitrogen gas react with 3 moles of hydrogen gas to form 2 moles of ammonia, correct?
Yes.
Yes or no? Yeah. So by that, what we come to know, they have given us if 1 mole of nitrogen react, you will get what? 2 moles of NH3.
NH3.
Yeah. When 1 mole of nitrogen react, you will get what? 2 moles of NH3. If 4 moles of N2 would be react, right? Then how much?
8.
We will consider it as a x. Go for the cross multiplication, how we did yesterday. 1
8,
into
ma'am.
x is equal to 4. So x is equal to 4 to the 8 moles. Isn't it?
Yes, ma'am.
Yeah, see the answer. 8 moles of NH3 will form. Isn't it?
Yes.
Yeah?
Yes,
Yes.
ma'am.
See the now next is mass-mass relationship. This was what? Mole-mole relationship. If you know the mole of reactant, if you know the mole of product, you are able to calculate the number of moles of the reactants moles are given. You are able to find out the number of moles of product, right? So this is a stoichiometric relation in between reactant and product with respect to moles. Now we are going to see the stoichiometric relationship in between reactant and product with respect to mass. Clear?
Yes, ma'am.
Fine? Yeah. So what we are going to see in this, shall I erase it?
Yes.
Yeah. See now the next. It's quite easy, just you need to practice well. See now. Here see in that what is given. If you can read, you read it once. Fine. In the mass-mass relationship, what is given to you? Check. Fine. It relate the mass of species, okay, with the mass of another species, means mass of reactant with respect to mass of product. So how do we have to calculate? Calculation involving mass-mass relationship in that. In a general, following steps are adopted in a making necessary calculation. What steps you need to adopt? See. Write down the balanced molecular equation for the chemical change. Whatever change would be happen in a reactant, means you have to write the reactants at one side and products at the another side. Means you need to write the balanced chemical equation first. Then the second step is what? Write down the number of moles below the formula for each of the reactant and product. In the second step, what you have to write? Number of moles of reactant and the number of moles of product. Third step you have to follow. Write down the relative masses of reactant and product with the help of formula below the respective formula. This shall be theoretical amount of the reactant and product. Third, you have to write what? Mass of your reactant and even the product. How you are going to calculate the masses? By knowing its molecular formula, right? You should have the formula, and by using the atomic masses, a calculation of molecular formula, you are able to find the mass of reactant and the product. Fine. See the next, fourth one. By the application of unitary method, mole concept, and the proportionality method, the unknown factor or the factors are determined. Which method? Unitary method,
Unitary
mole
method.
or by using the proportionality method. You are able to calculate the different factors. One factor would be given and other need to be calculated. Fine. So we are going to see one example by using these steps. Means like we are going to use all these things in that particular example, whether you are able to calculate or not. Right? We will see. So here they have given the chemical equation. See, that would be what? Twice NaHCO3. What is this? Sodium hydrogen carbonate or sodium bicarbonate. It is in solid state. When you heated it strongly, it will convert into sodium carbonate Na2CO3 plus H2O plus carbon dioxide. Correct?
Yes,
Isn't it? Yeah. Now this would be in a gaseous state. This would be in a solid state, right? Water would be obviously as it is heated, it would be in a gaseous state. Clear? They have not mentioned in the reaction, but then we should be aware, like it's as in a reaction, heat is involved. Whatever vapors would be generated, that would be in a gaseous state, vapors of the water. So what they have said, suppose the mass of NHCO3 being heated, a gram. We have to consider the mass of this NaHCO3 would be A gram. And we want to calculate the weight of Na2CO3 being produced by the heating of A gram of NaHCO3. Means when you heat A gram of NaHCO3, what would be the mass of Na2CO3? Means sodium carbonate. How much mass would be generated? That we have to calculate. Understanding? Yes or no? Yes or no? Understanding or not? What you have to calculate in this? What is the problem in front of you? You have a balance equation. In that you know the mass of one of the reactant and you have to calculate the mass of one of the product. Clear? Yes? Come
Yes,
on,
ma'am.
sub students. It's very important. If you speak, then only everything would be like communicative way. Means you teaching and learning would happen. Only if I babble in front of you, it is not of any use. Understanding your involvement is very, very important. Now see, next step, what we have to do, we have to calculate the number of moles of this NaHCO3. For that, you should know its molecular mass, isn't it? What is the molecular mass of this? Come on, calculate it and let me know.
Okay,
Formula
ma'am.
is HCO3. Sodium is nothing but what? Atomic mass 23. Hydrogen is 1, carbon 12, and oxygen is 16. Come on, calculate it fast and let me know. How much it will be? Speak up.
61. Ma'am, what is the like mass of Na? Sodium.
Sodium 23, I said you.
Okay.
Atomic number is 11 and the mass number is
84.
20.
84.
Yes. So this is what, see, directly I'll let you know 23 for sodium, 1 for hydrogen, 12 for carbon, and 3 into 16 for oxygen. When you do this calculation, you will get the mass 84. It would be AMU, and when you convert it into gram molar mass, it will be gram. Right? Yes?
Yes.
Correct, right? Now I have to calculate the number of moles of NaHCO3. So moles of NaHCO3 is equal to, that will be what? Given mass, that is A gram, upon its molar mass, that is 84. Correct?
Yes, ma'am.
Yeah. So what you got here? The moles of NaHCO3. Got it?
Mm.
Yes or no? Fine.
Yes, ma'am.
So by chemical reaction, what you come to know here? Check it. 2 molecules of NaHCO3 when you take, you will get 1 molecule of Na2CO3. Isn't it? Yes or
Yes,
no?
ma'am.
Same. If you have to like find out the number of moles of Na2CO3, how many moles you need to take again? 2. What you come to know here, if you take a 2 moles of NaHCO3, you will get only 1 mole of Na2CO3. So whatever moles of NaHCO3 you will get, from that, if you have to calculate the number of moles of Na2CO3, you have to divide it by 2. Isn't it? Do you
Like
have
what?
to do it or not? By the
Like what?
proportionality?
Can you repeat?
Yes, sure. I'm going to repeat. Check it. What I said here, 2 moles of NaHCO3 is there.
Hmm.
Yes.
Yes.
It will form what here? Only 1 mole of Na2CO3. Correct?
Yeah.
Now here you get number of moles of NaHCO3 is nothing but A upon 84.
Hmm.
Right?
Yes.
If I have to calculate the moles of Na2CO3, what I'm going to do, I will divide it by 2. Yeah?
Okay. Yeah.
Understood. This is for 1 mole, means 2 mole. 2 moles of NaHCO3. 2 moles of NaHCO3 produce how many? Only 1 mole of Na2CO3. If it is 2 mole, and if I have to convert it into 1 mole, I will divide it by half.
Yeah.
Clear?
Yes,
Isn't
ma'am.
it?
Yes.
Understood?
Yes.
Yes or no? Yeah. So thus, weight of Na2CO3 produced is equal to moles of Na2CO3 into molecular weight of Na2CO3. Now you get here what? Moles of Na2CO3. You have to calculate what? Mass of Na2CO3. How we have to calculate it? Already we have a formula. What? Shall I erase this? This part?
Yeah.
Yeah. This I hope all of you have wrote. Isn't it?
Yes, ma'am.
Yeah. Now, what you have to do here in this, check. It's very means easy trick, but then if you understand, then only. Okay. Now here, see. Yeah. Number of moles of Na2CO3 you got. That is what? 1/2 into A upon 84. Correct? Yeah. These are the number of moles. How you calculate the number of moles? Moles are equal to given mass, right? Upon molar mass. Correct? Molar mass or molecular mass in grams. Gram molar mass, we can say. Isn't it?
Yes,
Yeah.
ma'am.
Number of moles that we have, that is 1/2 into A upon 84. This is for Na2CO3, correct?
Yeah.
Okay. Mass we have to calculate. That is not given, right? And gram molar mass of Na2CO3 you can calculate by knowing the formula. What it will be? Na2CO3 is equal to 2 into 23. 23 for sodium plus 1 into 12, that is 12 for carbon, plus 3 into oxygen, that 16 for oxygen, correct? Do this calculation and let me know. Tell me, what would be the answer?
106.
How much?
106.
106. Sure? Are you sure?
I think so.
Fine. You have to divide it by 1/6. Clear?
Yes, ma'am.
Take it, calculate it and let me know. Take your time and calculate. Don't worry. I think now I'm not going to disconnect. Right?
Yes, ma'am.
So what would be the correct answer now for this calculation?
106.
106. Okay. Now mass, if you have to calculate, what you're going to do? Number of moles into molar mass, right?
Yes, ma'am.
Yes or no? Yeah. So what would be the mass then? Mass is equal to this 106 is divided. It goes that side, it become multiply, correct? So you will get 106 to A upon what? 84, na? 2 into 84.
2 into.
Is it?
Yeah.
So you can divide it by 2. 2 2s are 4, 2 5s are 10, 2 3s are 6. So your answer would be mass is equal to 53A upon 84. Means if by using this, you are able to calculate the mass of Na2CO3. Understand?
Yes, ma'am.
Clear?
Yes.
See here, it's been given to you. I'll show you how it's been explained to you over here. Check. See, 1/2 into A upon 84 into 106, which is a molecular mass of your Na2CO3. You get 53A upon 84 grams weight for the Na2CO3. When your NaHCO3 mass is equal to A, and it is given. Means if you know the mass of NaHCO3, you are able to calculate the mass of Na2CO3, which is not given. Understand? So by using balance equation, you are able to calculate the stoichiometric calculation for the mass of one of the content in your reactant or product, right? If reactant is given, you're able to calculate product. If product is given, you're able to calculate reactant. Understood? Easy? Or still confusion, or I have to explain it again?
No.
If it is so, I can, no issues. If you ask me, ma'am, I haven't understand, I have one more time explanation, explain it again, it's fine, I can do that. Let me know. Your understanding is very important.
No problem.
Clear?
Yes, ma'am.
Fine. All of you are clear or only one of you?
Yes, ma'am.
Fine. So the next is mass volume relationship. Shall I continue or I have to stop?
Your wish.
Huh?
Your wish, ma'am.
It's up to my wish. Oh my God. If it is so, then fine. Okay, one more question I would like to ask you all, four of you. I miss three of you. Let me know whatever I'm teaching, are you getting it properly or not?
Yes, ma'am.
Okay, Preetham said yes. What about you, Dhananjay and Jaswant?
Yes, ma'am. I can
Yes, ma'am.
understand.
Everything you understand in a clear manner? Yeah, Dhananjay?
Yes, ma'am.
Okay, fine. Thank you. It's very important for me as a teacher. I would like to take your feedback. And if you face any difficulty anywhere while solving anything by yourself, please do ask. Okay, don't be hesitate. Like, don't you feel like that what ma'am will say, ma'am will give answer or not? It never happened. And if you feel like problem is quite complicated, that time do one favor. Just pose the problem to me a day prior. Okay, fine. So I won't disappoint you at all, ever. I'll try to give all the answers. Fine. So shall we go for mass volume relationship or shall we continue it by tomorrow? Because as you know that Ramzan is going on and I follow all the like I follow this religion and I have to prepare something right now. So I feel like I'll just quit for today. If possible, I'll extend the class tomorrow for 15 minutes. Is it okay?
Okay.
Yeah, everyone is okay with this?
Yes.
Okay,
Yes,
ma'am.
ma'am.
Yeah, fine. Maybe I wanted to exchange the timing as well. If possible, I'll take early classes instead of evening. Okay. I'll
Yes,
speak
ma'am.
with management once. Fine. Thank you. Thanks a lot
Thank you, ma'am. Have a
for
nice day.
cooperation. Thanks a lot.
Okay, ma'am.
Yeah. Bye. Take care.
Bye.